Hi guys, today we are going to see the logistic regression, which is very famous, or you can say very simple binary classification algorithm. We have implemented logistic regression from scratch with using the gradient descent method. So what we are doing is we just take the formula for your loss and we just take the dl by dw or dl by dp. It's nothing but the gradients. So it's simple gradient descent method that we are implementing. So what's happening here is first we will initialize our W and B at any random point. You can try any random point. What we are doing here is we will calculate the loss gradient and this dB or dl by dB gradient with respect to intercept and try to update it using the eta into dw. This is some simple gradient descent formula. Right? Eta is nothing but our learning rate. You can say that. And at start you can give any random value. You can give either 0 or let me show you in main function you can give even to -1 to 200, even you can give 2 million also, but it will try to converge, so it will minimize the loss. So what is the meaning of minimize the loss? So it will try to find out the line which fits the well. So let's start this. So basically, okay, just give me a second. So see, first we are taking this 2 and -1, so line is here and our loss is very much higher, right? So there are total 282 iteration, as you can see here. So it's every iteration it is trying to minimize the loss. See, if you see the loss value, it is going down and down. First it started with around 4.5 and now it is converging. What I mean by converging is it is trying to minimize the loss with the different value of W and B, right? So at each iteration what we are doing is we are taking the gradient with respect to W and with respect to B, and we are subtracting that gradient with the W but with some eta learning rate. So if I take the learning rate higher, this would be faster, but there are very much higher chance that this will oscillate also, correct? So choosing a good learning rate is also important, right? So it is trying different value of W and B and slowly it is trying to converge, right? So if I get line something like this, then it can classify my orange point and blue points perfectly, right? And we are using the gradient descent with the loss, and our loss what we are using is as it's trivial, this is logistic regression, so the loss is nothing but logistic loss or log loss for short. So log loss is calculating all the, you can say, predictions. So what logistic regression is saying, what is the probability that this point belongs to 1, right? So it gives you the probability for the positive class. So what we are doing is we are maximizing the probability for the positive class and minimizing the probability for this zero class, or you can say negative class, or negative class. It can be represented as 0, but in other form of logistic regression it is also represented as -1 also, right? So slowly it is trying to converging, and we have given some tolerance. What I mean by tolerance is let's say I am updating my value of W and B, I am getting some loss. So if loss is not improved by, let's say, 0.00006, it's nothing but 10 to the power -6, then it's good to stop, right? Because we have like good line, or you can separation line for these classes, right? So we are good to stop. So that is defined by the tolerance, right? How much, like how much point or how much accurate you want the line, or how much should be the minimum update to the loss. As you can see, this W and B are not changing much, and our loss is also not changing much, right? 23196, so it is changing after like fifth decimal point. So our tolerance is 1e -6, that's nothing but 10 to the power -6. So if loss is not decreasing so much, so then we are good to stop. So that's all about our epoch. So epoch is nothing but the one round. Like I am calculating, I'm updating this W1, or I'm going through all the points once. So it's one epoch. Total epochs we have is 282. It starts with 0, so it stops at 281. Right? So it's asking, enjoy the show. Hope you like it, right? I will be sharing this code in the description, and if you have any doubt, feel free to post it in comment section and let me know if you enjoyed the show or not. Thank you.